So my name is François Tigeot, and I'm reachable on IRC or by email. I generally hang out on Freenode. I'm an independent consultant and system engineer. I'm an X11 and a BSD user since many years now. I've been a Dragonfly developer since 2011. I originally ported the i9-15 and a Radian driver to Dragonfly. And I have been updating the i9-15 drivers and then. Dragonfly is a Unix-like operating system. It's a BSD descendant. It was originally forked from FreeBSD in 2003 by someone called Matthew Dillon, who is a sort of genius in his own way. Dragonfly is high performance and scalable. It uses per-core replicated resources. And many operations are naturally lockless. So it really likes high core count, SMP systems, and so on. Dragonfly uses an innovative Hammer file system. A newer version will be coming this year. It's really great for disaster recovery or heavy storage in general. The Hammer file system can retain history. All transactions can be kept on disk for up to 60 days. And history can be streamed between local and remote file systems. It can be used in a sort of real-time way. So it's really great for disaster recovery and general heavy storage systems. There's also integrated deduplication, cheap deduplication. You don't need tons of memory to deduplicate data. It's great with small servers like machines having only 4 gigabytes or so. And I have been successfully using it on some client systems using DNA or proteins or generally scientific data. And now I will focus on the graphics drivers. So all graphic drivers these days are based on Linux. There are many people, corporate developers developing, writing graphic drivers for Intel in particular, but also AMD and so on. Nobody is working on Dragonfly. All of them work in Linux. I guess nobody has heard of Dragonfly in that area. So I have to manage with the current situation and port the Linux drivers to Dragonfly. And the easiest way I found to do that is actually not to port the drivers, but to re-implement a Linux subsystem in the Dragonfly kernel. Most modern graphics in Linux use something called the DRM subsystem, which means Direct Rendering Manager. This subsystem and the drivers themselves directly use tons of Linux APIs. And I had to re-implement these APIs and in general make the drivers believe they were running in a Linux kernel. So for that purpose, the Dragonfly kernel can be considered an implementation of Linux. I was quite lucky for many BSD systems already at limited Linux API support, limited Linux API implementations. When I first started, OpenBSD was probably the most successful BSD for DRM support. There were many APIs I took. Well, I took the implementations from OpenBSD. There was also specific subsystem for some high-performance network devices in FreeBSD using Linux APIs. At some point, NetBSD people decided to also port the DRM subsystem and implementing many things missing in Dragonfly. So I took a bit from all other BSD projects. We also had some subsystem we managed to use to re-implement other Linux APIs like IDR, which is a sort of a small integer registering subsystem. Occasionally, we also took some implementations from Linux itself. Contrary to popular beliefs, all the Linux kernel code is not under a GPL license. There are many pieces under more liberal licenses like MIT, X11, and so on. And this is particularly true for DRM subsystem and drivers. Our Linux compatibility layer keeps growing from year to year. We now have more than 100 include files. They mostly are wrappers for other APIs which were already implemented as Unix APIs or BSD-specific APIs. Most of the wrappers are under too close BSD or MIT license. The i915 kernel driver is mostly at the same state, as the one found in Linux 4.7.10. We support Core 2 to cable-like GPUs, which makes it GPUs from about 2005, 2006 to the current generations of hardware. More recent Linux version support is being worked on, and many people have helped. General history of the i915 kernel driver. In 2010, there was a GSOC, Google Summer of Code project. A student called David Shao tried to work on i915 support. He did many things, but for many reasons, I don't really know. His work was not integrated into the Dragonfly source code repository. So it was a bit of a waste. But at least when I tried to understand what happened years later, I found many discussions and ideas I simply could reuse without trying to waste time finding out myself what had to be done. I started to work on porting i915 2 years later, in summer 2012. At that point, FreeBSD had just released new port of i915 from Linux, and it was working on current hardware. And since FreeBSD and Dragonfly were somewhat closed due to the shared history, I decided to port the drivers from FreeBSD and not directly from Linux. 1 year later, we had the driver working reasonably well. We had to implement some low-level support for cache management, which we didn't expect at all at first. But that really was the missing point, the missing piece, which allowed us to get the driver working. After that, I discovered FreeBSD had stopped updating its driver. Nobody told me exactly what was happening or what the situation was. People in the FreeBSD community apparently still believed a work in progress update would be committed, would be pushed in the future, but nothing happened. So I didn't really understand what was going on. And at some point, I decided to try porting newer changes from Linux directly. And it was not until 1 year later and we had working Haswell support. Haswell was the newest Intel GPU generation at the time. And since then, I have been steadily upgrading our Linux driver version. And we are now at the Linux 4.7.10 level. And all currently sold i915 hardware is supported out of the box. DRAM Radian is another driver. I started to port it 1 year later than the i915 driver. It is currently mostly synchronized with the same Linux version, Linux 4.7.10. It uses a special subsystem for memory management, which is called TTM. Well, virtual memory management is hard. Not many people understand really what is going on at its low hardware level. So it has been stuck on the Linux 3.11 level for 4 years now. There were also many people involved in debugging and helping to improve various subsystems related to Radian support. So the history was in summer 2012, 2013, I started ported the Radian driver. It was working about 1 year later. At that point, we updated it from time to time to newer Linux versions, but it has been somewhat neglected. It was not until this year that David Chaos, the original GSOC author, decided to partially update it to Linux 4.7.10. But unfortunately, there are problems with this update, and there are talks of a partial revert. The AMD GPU driver is a new GPU driver for newer Radian hardware. I don't really know what the Radian codenames mean in terms of commercial graphic card names, but it's generally required for newer GPU families. And nobody is known to be working on it, and this has not changed since 2015. Nouveau support. Nouveau is the Linux kernel driver for NVIDIA hardware. NVIDIA hardware was never really well supported since NVIDIA itself, the company, loves to push its proprietary driver everywhere. Support has actually regressed since at some point there was a 2D accelerated driver in Xorg, but it has not been updated for years and cannot be used with recent hardware. So almost nobody in the DragonFly community has NVIDIA hardware. I still played a bit with the driver, and it poses an interesting challenge. Some file names are present with the same names in different subdirectories, and our build system cannot compile them. Well, I guess it could be fixed by renaming some of them or changing the build system a bit, but there has not been enough interest for people to do that. And Well, actually, there was a bit of interest for NVIDIA hardware, but in order to disable it. And the only improvement we've had since 2015 on that front is it is now possible to disable NVIDIA hardware on hybrid laptops. So people can now force the use of the i9-15 driver and use their laptop out of the box with it. Visa, we also have a Visa driver. It's interesting. It's basically using small firmware instructions. There's a very old and low-level BIOS API, and it allows the use of NVIDIA hardware as a dumb frame buffer. It can also be used with some other GPUs like Intel and Radian, but since they have accelerated drivers, it's only really useful for NVIDIA at this point. Of course, nothing is accelerated, so if you try to display static images like pictures and Xterms and so on, it's fine. But if you try to play video or animations, well, everything will be dog slow. Now, all of these drivers, except Visa, use the generic DRM subsystem. And it's a bit of a mixed bag. In order to be able to support current hardware and update drivers and so on, I have somewhat neglected it. And so we have some parts up to Linux 4.7.10, but others much older. Like for example, we have no DRM master and no DMABF support. Well, it's not really been problematic with applications, but at some point it will probably become to implement the missing pieces. One of the recent changes was related to the I2C subsystem. The I2C bus is a low bandwidth bus, and general, it's used to provide additional information on video outputs, like for example HDMI cables or even the old VGA connector. Monitors can provide describe their preferred video resolution and other capabilities, so that PCs and other pieces of equipment can auto-configure themselves to use it automatically. Of course, it isn't always perfectly working, like the HDMI cable at the start of this presentation. I'm sorry for that. Anyway, the I2C subsystem is a Linux subsystem. I re-implemented it from scratch and finally pushed the changes to the DragonFly kernel in October 2016. It eventually replaces an old FreeBSD and DragonFly specific subsystem called IIC, which was completely different. It used completely different APIs and for no good reasons. It was a bit of a hindrance when trying to upgrade the driver versions. And it made it much easier for me to update the i9-15 driver. And at some point, it would probably be a good idea to change the Radian driver to use it also. It's currently only used by i9-15. Another big change this year has been VGA switcheroo support. VGA switcheroo is another Linux subsystem used to manage hybrid graphics. Many laptops nowadays are dual GPUs, since Intel always integrates a GPU in its low-end and low-power processors. But some companies like to also provide a more powerful GPU, like NVIDIA 10 something MX and so on some laptop models. And so we need Visual Switcher support in order to manage these two GPUs, to be able to use the i9-15 GPU if the hardware was configured to use a discrete Radian or NVIDIA GPU by default. So someone called Peter Must ported it in March of this year. And it allows the use of i9-15 on hybrid graphics laptops. Peter Must also ported a different subsystem called Apple GMax. And it's really specific to some Apple laptop models, some PowerBooks and PowerMacs. Some hybrid graphic laptops provide both GPUs with full video outputs. If you program the i9-15 GPU, you see something on the screen, or on an external video output like a VGA port. Same with the NVIDIA or Radian discrete GPU. But on some particular Apple models, the video outputs are not directly connected to either the screen or the cable, the plugs you can use on the case. They are connected to a different component called GMax. And so we have to program that chip to be able to choose whether to use i9-15 hardware or NVIDIA hardware, for example. So since April of this year, we are now able to also force the use of i9-15 hardware on Apple laptops. Unfortunately, this code was directly ported from Linux and not re-implemented. It's GPL-v2 code, so we put it in a separate place, just to be sure not to mix it with more liberally licensed code. Now about user and software. Dragonfly uses a system called dports to create packages. Dports is framework based on FreeBSD ports, which is a repository of package building instructions. And we automatically patch FreeBSD ports to improve Dragonfly support. So we have an automatic adaptation layer and automatic tests, validation, and so on. It's single-handedly maintained by a guy called John Marino, and we now have more than 25,000 packages. And it's really a great system for Dragonfly is a small community, and we don't have enough people to maintain such a number of applications. So it's great we are able to reuse FreeBSD porters work and automatically create packages from this great work. We have, well, not the current version of Xorg, but the previous one. We have generally current versions of drivers. The XF86 drivers are 2D drivers. And for Intel, this is a bit special. For Intel has stopped releasing newer versions, and we now have to directly use code from their Git repository. So this one is not based on FreeBSD ports, but is managed locally. And Cairo is a library for generally used for 2D accelerations and displaying pictures and so on. So it's reasonably current, and Misa is a 3D driver library, and is also reasonably current version. Concretely, everything related to 2D operations and even 3D OpenGL works fine. Most graphic environments work fine. I don't think we have any GNOME users, so I don't really know about the state of GNOME, but other desktop environments, so like METI or KDE, are known to work well. People even wrote to the Dragonfly IRC channel to congratulate us about the state of KDE support at some point. We also can play 3D games, so generally use OpenArena as a testing framework. Be sure 3D operations still continue to work fine after driver updates. And it's doing great. Well, I think that was quite fast for such an old game. Other people have also tested GPU calculation frameworks. There's something called Binet. I don't really use it myself, but I've heard it is generally in a good state. There's also Wayland. Wayland is a bit mysterious for me. It's a sort of future Xorg version or replacement. Applications have to be ported, so I can't simply use my usual window manager and tell it to use Wayland. So that's why I've not really tested it, but other people have, and apparently some versions worked fine. Especially with the i915 driver. The challenge with newer versions is Wayland or some part of Wayland. I've heard about Western now requires a special library called liminput to manage mouse events, keyboard support, and so on. So people are working on it, but I'm not really involved myself. We have difficult spots, of course. One of them is virtual memory management. In general, graphic drivers now try to manage virtual memory. They have tentacles deep into some kernel virtual memory subsystems. And it's hard to make sure things work properly with non-Linux VM subsystems, since the Dragonfly VM is very different from the Linux one. The VM models are not the same. But VM is something which is a bit out of my league, so we're lucky to have Matthew Dillon for that. I think at this point he's the only one to really understand what's going on with such a low-level subsystem. And of course, the big challenge with i915 is it keeps being rewritten and rewritten. Intel people constantly make changes, much more than with other drivers. And right now, I think I have more than 800 commits from one Linux version to the next. So this makes it difficult to continue updating it. So we also have non-problem, of course. Some recent GPUs have slight display corruptions in some cases. I've heard about scrambled mouse pointers and so on. Well, minor things. And it's generally only visible on most recent GPUs. So it's possible our i915 driver is not stable enough for carbylate support, for example. So updating it to a newer Linux version could probably fix that. We also have problem with some acceleration features like last level cache support in the 2D driver. It's probably something we're not doing correctly. in memory management, virtual memory management, and our kmalloc functions also are known to behave differently than Linux. One thing I didn't understand at first is Linux version of kmalloc provides physically contiguous memory ranges. But the DragonFly version only provides virtually contiguous memory ranges. GPU and CPU parts of the chips are not completely coherent. If we write something from the CPU to cache memory, it will not be completely pushed to real memory, and the GPU part of the chip will not see it. Same in the other directions. So we have to make sure cache memory is properly managed, and we should try to fix our kmalloc function to make sure it uses physically contiguous memory ranges. So that's probably one of the reasons we have some slight display corruption in some rare cases. Now about the future, well, an obvious future thing to do will be to continue updating the i915 driver. At this point, I guess most people, most DragonFly users have Intel hardware, Intel GPU hardware. Some rare people also use Radian hardware, but a rough guess of my part will be more than 90% of people use Intel hardware. Most people use laptops these days, and most laptops use Intel chips. So we need to continue updating the i915 driver. Well, of course, Intel keeps creating a new driver family, new GPU families, so we have to. Otherwise, DragonFly will not be able to work on recent GPU families and on recent laptops. The Radian drivers also need some love, but since there is such a low amount of users, it's a bit difficult to improve. It still uses all the APIs and FreeBSD or DragonFly specific code. It has not been fully based on Linux. Other things to do will be to use formal test shoots and run benchmarks and so on. Try to find out the more, in a sort of automatical way, regressions and fix things immediately. Another future things to at least investigate is high-resolution timer support. Linux uses a subsystem called HR timer. And we currently have an implementation of that subsystem in DragonFly, which is based on the old callout mechanism, which was an original BSD mechanism, probably implemented in 1987. And it's not high resolution at all. It's about, it fires about 100 times per second. At some points, it would be interesting to re-implement high resolution timers with a real high resolution backend. And some developers, well, I think it was mostly Imre Vadas, has begun to investigate. And in theory, using this facility properly will mean we could have important power savings. So right now, a modern laptop such as Skylake ones uses about 2 or 3 watts per default just deploying XO pictures. And if we manage to drastically limits the number of times interrupt or periodic functions fire, we could tremendously decrease CPU time, decrease used CPU time, and generally improve power savings and get a much better battery life on a laptop. Now this is about the people involved. Well, I ported the drivers. David Shaw was the original GSOC student, which gave us many ideas. And many people were also involved and helped for various things during these last 4 years. So I'm done. Do you have any questions?
You talked about formal test suites. Are there any, and how do they work?
Well, there's a non-Intel test suite. The name escapes me at the moment. But at some point, some people try to use it. There's also an OpenGL test suite and an Xorg one. But I've been relatively busy trying to keep up with Intel upgrades, and I've not properly used them since a few years now.
Have you ever tried to upstream some small changing to the Linux kernel code? Something that you could benefit, or some other BSD could benefit?
Yeah, at some point I found a hardware bug on a particular supermicro motherboard, and I reported it as a bug on some channel. I think it was GMax, I'm not so sure anymore. And the fix was implemented by one of the Intel developers. And it's now in the Linux kernel. But in general, we don't have many things to push, since we're already using a relatively old version of Linux. At some points, I have found bugs in the i915 drivers, driver, or maybe once in the DRM subsystem in general. But when I checked on the current git master of, it was already fixed. Yeah. So no, right now our focus is not on trying to push changes to DRM Next or Linux. It's about being the most Linux compatible as possible.
Hi. I saw on the mailing list of FreeBSD that they're also making a Linux KPI for porting DRM drivers. Is there some, do you work together with each other, or are they totally separate projects?
Well, it's a separate project in the sense that it's being maintained in a FreeBSD. But that KPI subsystem was originally based on more limited Linux, also Linux KPI subsystem, which was called differently. I don't remember the name. It was used for high-performance network hardware and Mellanox hardware. Often, yeah. OFED, yeah. That was the OFED stack. And I originally took some of that code from the OFED stack. If you check the copyright mentions in the Linux something.h drivers, we have in DragonFly code originating from FreeBSD and the OFED stack. And in the other directions, one of the OFED developers took some of my changes and incorporated in that Linux KPI subsystem. So changes work both ways, but they cannot really be maintained in a common tree for many details are specific to the DragonFly or FreeBSD kernels.
Does Dragonfly implement the user pointer interface?
Sorry, I didn't completely hear.
Does Dragonfly implement the DRM user pointer interface?
The DRM user pointer interface?
Right, so it lets you basically malloc memory and then use an I/O control to create a gem object that's backed by user malloc memory.
Yeah, I see what you mean. Yeah, there are some IOCTL which allows the use of user-generated data without having to copy it and change it in one way or another. I think this IOCTL is disabled at the moment. Well, implementing it requires some work, and well, I prefer to keep upgrading i915 driver versions than trying to fix that. It could be helpful to improve performance, but right now what we need is to continue updating the driver and make sure we still work with newer Intel hardware. So it will probably be changed at some point, but this is not the highest priority right now.
Also, in recent MISA and so on, there is a lot of work where they are using file descriptor passing instead of shared memory directly. I forgot the name of the code that has been used for that. Have you done some work also to support these file descriptor passing APIs rather than the old shared memory interfaces?
Well, not really. I have not been deeply involved with Meta since a long time. One of the recent MISA changes was a bit problematic, but it was, I think, 1 year ago. Maybe this is a performance optimization, but I have not. It's a security issue. Okay. Well, no, I have not really followed that change. I'm mostly focusing on the i915 drivers these days. Well, in general, we take Mesa packages, the Meta port as present in the FreeBSD ports tree, and we don't really change it. Okay, so say yeah, at some point we will probably need to add support to the new kernel interfaces, but right now nobody has really thought about it.